Now let's talk about adding and subtracting polynomials. Before we can do that, though, we need to define what a polynomial is and have some vocabulary so that we can talk about them. All right, so let's begin with what's called a monomial. Let's say you have a number, a constant number, for example, the number 2. Let's say you have a variable. It can be x, or we can use any other letter we like. And let's say we have a power. Now here, we're going to be able to use any whole number power that we like. No negatives, no fractions or decimals, only whole numbers. Okay? That's the only restriction. This can be any number we like. This can be any variable we like. And if we like, we can even have more than one variable. The power does have to be a whole number. 0, 1, 2, 3, 4, 5. No negatives, no fractions or decimals. An expression that looks like this is called a monomial. All right. This number, the constant in front, is called the coefficient of the monomial. This is the variable of the monomial. And this is the exponent, also sometimes called the degree of the monomial. Exponent. You can also say the power, or you can even say the degree of the monomial. Now this degree, again, this coefficient can be any real number. Positive, negative, whole number, fraction, decimal, it doesn't matter. Any whole number. Oh, sorry, any real number. But this must be a whole number. Examples of monomials are things like, well, like we just said, 2x to the power 5. Again, this coefficient can be anything we like, so we can say negative. For example, negative 3x to the power 4. We can have a fraction. We can say 2/5 x to the power 3. We can use a decimal. We can say 0.4 x to the power 2. We can use the number 1 if we like. Well, if it's the number 1, then we generally don't write it. So for example, x to the first power, that's like saying 1x to the first power. So here, that coefficient can be the number 1, but when we have the number 1, we generally don't write it. 1x, really we just write x. You also can have just a regular constant number. For example, the number 8. That is itself a monomial. Now you might say, well, no, it's not, because it doesn't have a variable with a power on it. But remember, the power can be any whole number, and that includes the number 0. So you could think of this as being 8x to the power 0. And thinking back, we define x to the power 0 as the number 1. All right, so 8x to the power 0 is like saying 8 times 1, which would just be the number 8. So that means that the number by itself is considered still a monomial. All right, so here we have 1, 2, 3, 4, 5, 6 monomials. All right, so what's a polynomial? Well, a polynomial is what you get when you add or subtract monomials together. Definition. A polynomial is the sum of monomials. Okay. So right here, if I were to stick plus signs between all of these, this would become a polynomial. Now notice right here, you say plus a negative 3x to the fourth. Plus a negative, we usually just write that as minus. So here, the definition is the sum of monomials. But really, you can have plus a negative. You can think of that as a minus. Okay. Whenever you add together monomials to form a polynomial, the monomials, oops, I don't know how to spell, the monomials that are added together to form a polynomial are called the terms of the polynomial. So here, this has 1, 2, 3, 4, 5, 6 terms. Here, the term includes the negative, because here we're adding a negative 3x to the fourth. Since the monomial itself included a negative, and that's what was being added in, the term itself includes the negative as well. So terms can be positive or negative. Depending on the number of terms that a polynomial has, we can designate that polynomial with a different name. So whenever something has one term, for example, 2x to the fifth power, that's called a monomial. Now, if you have two terms, and again, it doesn't matter what those terms are as long as you have two of them being added together. For example, 2x to the power 5 plus 4x to the power 3. That's called a binomial. Mono meaning one, like monorail, a train with one rail. Binomial meaning bi meaning two, like bicycle, two wheels. If something has three terms, for example, 2x to the fifth plus 4x to the third minus 2x to the first power. Whenever we have a first power, we generally just don't write it. X to the first is just x. When something has three terms, you call that a trinomial. Tri meaning three, like tricycle, three wheels. Triceratops, my favorite childhood dinosaur, three horns. Okay. And if something has four terms or more, it doesn't have a special name. Those are just generally called polynomials. If the polynomial has four terms or more, it doesn't have a special name. Those are just referred to as polynomials. Now you'll notice here that every polynomial that I've written so far has the exponents starting with the biggest one and going down to the smaller ones, 5, 4, 3, 2, 1, and then this one has no exponent. 5 and 3, 5, 3, and 1. That is a typical way of writing a polynomial. Whenever we write a polynomial, we want to write it with the biggest power first down to the smallest power. I want to keep those in order. The reason for that comes apparent later when we actually start using polynomials for things. It turns out that keeping things in a particular order makes some processes much simpler to work with. Having these written in any other order, although it still does mean the same thing, they're going to be harder to work with. So we want to write these in descending order. So note, for convenience and for simplicity of some of our things, some of other things that we'll be doing, polynomials are conventionally written in descending order. With terms written starting with those of highest degree, highest exponent, highest power, whatever word you want to use, the biggest one of these, highest degree, down to the lowest. And again, it's not like it's not a polynomial if you don't write it that way. It's not like it's a different expression. If I write this at the front and this at the back, it still means exactly the same thing. But it will be harder to work with in just about every context. So by convention, for the sake of simplicity and for the sake of making other things easier on ourselves, we write things in descending order, with the terms written starting with those of the highest degree down to the lowest. So whenever you have the degree of a polynomial, what you do is you look at the degree of the first term. Since you're always written in descending order, the degree of the first term is going to summarize things about the polynomial. when you start graphing things that involve polynomials, that number becomes even more important. But for now, just knowing that this is a fifth degree tells you that no other term is going to have any power bigger than the fifth degree, because again, they're written from the highest down to the lowest. This number right here is going to help you summarize things about the polynomial, and it's going to help you learn things about its graph in later topics. So what we want to do is we want to talk about this degree, and we name it. So here, definition. The degree of a polynomial is the biggest degree among its terms. If this was written out of order, it wouldn't suddenly change the degree. If you accidentally wrote this with, say, for example, 4x to the third in the front and then 2x to the fifth, the degree would still be 5. The degree of the polynomial is the biggest degree among its terms. All right? Whenever you have the term with the biggest degree, that's called the leading term. Now, usually it's written in the front, hence the name leading term. However, if you write things out of order, it doesn't magically change the degree, or it doesn't magically change things about the terms. So the term that has that biggest degree is called the leading term. The term with that biggest degree is called the leading term. And again, typically it's called the leading term because if you write things by convention, if you write things in descending order, then it will be the first one. So it'll be leading, it'll be in the front. The coefficient of the leading term is called the lead coefficient. Just like that. So as an example, let's say we have 8x to the power 9 plus 7x to the power 4 minus 16x to the power 2. All right, this is a trinomial because it has 3 different terms. It's written in descending order because it starts from the highest power down to the lowest power, 9, 4, 2. Since it's written in descending order, then we know that the degree of the polynomial is got to be this degree in the front. And even if it wasn't in descending order, we would still find it by looking at the biggest degree that we have. So this is a trinomial. Well, more specifically, it's a 9th degree trinomial. The lead term of this 9th degree trinomial is this 8x to the 9th power which means that the lead coefficient is the number in front of that, the constant 8. Now remember, this is a trinomial, so it does have 3 terms. The leading term is 8x to the 9th. However, the remaining terms, so here I'm just going to list all the terms. We already have the leading one, 8x to the 9th. The next term is 7x to the 4th. The last term is minus 16x squared. Remember, whenever it's minus, that's because that minus came with the term. Otherwise, it would be plus. Here, the coefficients of these terms are these numbers in front, the 8, the 7, and the minus 16. Again, the negative is part of that number. All right, so for now, we just have a big vocabulary lesson. A polynomial is the sum of monomials. You're adding these things together. When you're adding the polynomial together by adding the monomials, those monomials are called terms. Depending on the number of terms you either have a monomial, a binomial, a trinomial, or anything bigger than that is just called a polynomial. If you write things in descending order, it's because you start with the biggest power down to the smallest. The degree of the polynomial is that biggest power, usually written in the front, and so it's called the leading term. The coefficient of that term is called the leading coefficient. So go ahead and give this a try. Go ahead and, first of all, you're going to designate the term. So like over here I said, it's a monomial, binomial, or it's a trinomial. It's a 9th degree trinomial. So give the degree and a label. And then you're going to state what is the leading, you're going to state all the terms, you're going to state all the coefficients, and then out of those, tell which is the leading term and the lead coefficient. So let me go ahead and leave that there as an example. Like that. You're going to go ahead and find the terms, the coefficients, designate one of them as the lead term and the lead coefficient, and then give a title to this polynomial. In my case, it was a 9th degree trinomial. So give this a try. Let's say negative 6x to the power 5 plus 8x to the power 3 minus 7. Okay, so go ahead and give that a try. Go ahead and pause the video, and when you're done, go ahead and unpause and we'll go through that together. All right, so let's take a look. We note that this is 1, 2, 3 different terms. Okay, so it's a trinomial. Now this is in descending order. Notice power 5, power 3. This one doesn't have a power, so it's power 0. Okay, so that's 5, 3, 0. That's in descending order. So that first number, that first term has the degree of my polynomial. So that's going to be a 5th degree, 1, 2, 3, a trinomial. It has 3 terms, hence the name trinomial. Those terms are negative 6x to the 5th power, 8x to the 3rd power, and negative 7. Again, note the negative is part of the term. The coefficients are the negative 6, the positive 8, and the negative 7. Like that. Note that each of these has a degree. Whenever you have a constant by itself, we mentioned once before, you can think of this as being negative 7x to the 0 power, because anything to the 0 power other than 0 is the number 1. So negative 7 times 1 is just negative 7. So here, these terms have a degree. This has degree 5. This has degree 3. And this one has degree 0. Keep that in mind. All right, now, whenever we have a polynomial, it is a number. And you say, well, wait a minute, what do you mean it's a number? That's not a number. Well, it's not, except it is. For example, consider this number right here, or consider this polynomial right here. Let's say we have 2x to the 3rd power plus 6x squared. Okay, what's a variable? Well, a variable is a number. Now, it's a number whose value can change. It's a number whose value I don't know, but it is still a number. Okay, well, what happens if I take a number and square it? Well, then it becomes a different number. Well, yeah, but it's still a number, isn't it? Same thing with raising it to a 3rd power. So now what happens if I take this number and multiply it by 2? Well, then it's a bigger number. What happens if I take this number and multiply it by 6? Well, then it's a much bigger number. But so what? It's still just a number. And that's just a number. And if I add 2 numbers together, guess what? This is still a number. So in spite of the fact that this is a bit more complicated than numbers that we're used to seeing, it's still just a number. Which means that I should be able to do the same things to this that I normally can do with numbers. I should be able to add them, subtract them, multiply them, divide them. I should be able to do anything that I can do with a regular constant number with one of these numbers. Okay, so how do I do that? Well, let's start off with the simplest operation that we're used to, and that's addition. Let's say I have this binomial. Now to that, I'm going to go ahead and add another binomial. Let's say I have 8x to the second power, 8x squared, plus 5x. Okay? So I'm adding one binomial to another. I'm adding one number to another. Well, we think about how we add regular numbers. For example, let's say you were going to add together 12 plus 315. You wouldn't just add all these digits together. You wouldn't say 1 plus 2 is 3, plus 3 is 6, plus 1 more is 7, 7 plus 5 is 12. That doesn't work that way. When you add, you don't add all the numbers together. You only add the ones that are in the same place value. So here you would typically write this as 315 plus 12. Notice ones are with ones and tens are with tens. You write these vertically this way so that you can combine the terms that have the same place value. 5 plus 2 makes 7. 1 plus 1 makes 2. And then the 3 doesn't combine with anything, so it stays at 3. 327. Adding polynomials is going to work kind of the same way. We want to add the ones that are of the same place value. You say, well, these are all in the ones place, right? 6, 2, 8, and 5. Well, okay, so that's not quite the right language. What we want to do is we want to add the ones that have the same degree. When you add polynomials, what you do is you combine the like terms. The like terms are the ones that have the same variable with the same power. So here, a small definition. Two terms are said to be like terms if they have the same variable and degree. So here, these are like terms, 6x squared and 8x squared. They have an x and a square, same variable and the same degree. Whenever you're going to add polynomials, what you're going to do is you're going to combine the like terms. You're going to add the terms that are like each other. Anything that isn't like these then doesn't combine. Just like over here, only ones go with ones, tens with tens, and hundreds with hundreds. Here, cubes go with cubes, squares go with squares, and first power go with first power. So here, to add these together, when you combine the like terms, you simply add the coefficients. So that's going to be 2x to the power 3. Notice that one doesn't have any other terms that are like it. There are no other x to the power 3 terms. However, these two are like terms, so those can be added by adding the coefficients. 6 plus 8 make 14x squared. Plus, your 5x has no terms like it, so we just leave it alone. So to add polynomials, we combine like terms. What about subtraction? Well, it's almost exactly the same. To subtract polynomials, add the opposite polynomial, then combine like terms. So for example, let's say we had 3x to the power 2 minus 5x, which is same as saying x to the power 1, plus 9, which is like saying x to the power 0. And now let's say from that polynomial, we're going to subtract away 2x to the power 2 plus 4x minus 12. Okay? We're still going to combine the like terms. But notice, to subtract polynomials, we have one extra step here. We're going to add the opposite. The way that works is, you're going to take the first polynomial and leave it as it was. But now instead of subtracting this polynomial, we're going to add its opposite, just like you do with regular numbers. If you have 5 minus 12, That's the same as saying 5 plus a negative 12. Subtracting a number is the same as adding its opposite. Subtracting 12 is the same as adding negative 12. So same thing will happen here. Subtracting this polynomial is the same as adding its opposite. Well, the opposite just means you're going to change the sign. But you say, well, there's more than one sign here. Oh, that's okay. Just change all of them. That's a minus 2x squared. That's a minus 4x. But now that's a plus 12. And now that we've added the opposite, we've changed this to addition of the opposite. Now we combine your like terms. 3x squared, 3x squared. Those are like terms. So when you add them, 3x squared and a negative 2x squared, that just gives you 1x squared, which you don't have to write the 1. You can just write it as x squared. Here, these are like terms. Minus 5x and minus 4x. That'll make minus 9x. And then this is like this one. 9 plus 12 will make 21. And that's our result. We add like terms. When we subtract, we change subtraction to addition, and then you add like terms. Note only terms that are like each other can be added. Here there was nothing like 2x to the third, so it just stayed the way it was. There was nothing like 5x, so it just stayed the way it was. But these two are like each other, so they combine. Okay, so only combine the ones that can be combined. Anything else just stays the way it was. To subtract, first we change subtraction to addition of the opposite. Notice the opposite just means we change all the signs over here. And then you can combine like terms. Squares with squares, x's with x's, constants with constants. So give that a try. Go ahead and add the following. You're going to take 5x to the power 4 minus 4x to the power 3 plus 6x to the power 2. And to that you're going to add 9x to the power 3 minus 12x to the power 2 plus 6x, like that. And then you're also going to do a subtraction problem. Go ahead and subtract 8x to the power 3 minus 9x to the power 2 plus 16x. And then we're going to say minus. Let's take 7x squared minus 11x minus 3. Okay, go ahead and give those a try. Go ahead and pause the video and go through those. Remember, to add polynomials, you're going to combine the like terms. To subtract polynomials, subtraction will become addition. You're going to change this second polynomial to its opposite. Notice the first one doesn't change, just like with subtraction of regular numbers. All right, first one stays the same, second one changes to the opposite. And then once you've changed it from subtraction to addition, then you can go ahead and combine the like terms. So go ahead and pause the video, give that one a try, and once you're done, go ahead and unpause and we'll go through it together. All right, so let's take a look at this. Here, we're combining any terms that are like each other. Notice there is no other term that has an x to the fourth, so that one's just going to stay as it is, 5x to the power 4. Right here, these are like terms though. You have 9x to the power 3 and minus 4x to the power 3. Okay, so they have the same variable and the same power, so those combine. 9 plus a negative 4, or in other words 9 minus 4, that'll give us a positive 5x to the power 3. These are also like terms. You have 6x squared minus 12x squared. So you're going to combine the coefficients. 6 and minus 12 make minus 6x squared. Notice that your powers don't ever change. 4 stayed 4. When you combine these, the power stays 3. When you combine these, the power stays 2. So when you combine like terms, only the coefficients are changing, not the powers. And finally, this 6x doesn't have anything that's like it, so it just stays as a 6x. And there's our answer. This one, we're going to change from subtraction to addition. So this first polynomial will stay exactly as it is, 8x to the third minus 9x squared plus 16x. Now, subtraction is going to become addition, and now we're going to take the opposite of this polynomial, which is going to change all the signs. That's going to become a minus 7x squared. Here, this is going to become a plus 11x. And this will become a plus 3. Subtracting a number is the same as adding its opposite. Subtracting a number is the same as adding its opposite. Same idea. So now we can go ahead and combine our like terms. There is only one term that has x to the third power, so that one's going to stay as it is. That's 8x to the third power. Here, these are like terms. You have minus 9x squared minus another 7x squared. That'll give us minus 16x squared. These are going to go together. This 16x combines with this 11x. 16 plus 11 will give us 27x. They're both positive now, so they add together to give you a positive 27. And then the 3 doesn't have any terms like it. There are no other terms that are just numbers without a variable, so those go together. So that one just on its own is plus 3 at the end. And this is our result. The other thing to note here is that even without being asked, we wrote this in descending order. We started with the biggest power term, added that, then the next biggest power term, then the power 2, and then the smallest power term goes at the end. Even without being asked, even without being told that's part of the problem, whenever we deal with polynomials, adding, subtracting, or doing anything with them, in the end, our result should be in descending order. Likewise here, power 3, 2, 1, and then no power at all. So that is it for now. If anybody has any questions, comments, or problems, please make a note of those and reach out. And I hope everyone has a nice day.